Lesson 6.10, Radian trig equations. This is level 3. This is as hard as they're going to get. And this is going to be only positive domain only. And then the next lesson will open up to where it's a negative domain as well. And so here's our unit circle. You're going to want this today. We know that when we open up an angle counterclockwise and go all the way around, that's 2 pi. But we also know that we could keep going around this circle as many times as we wanted. We've also talked about graphs of trig functions, and let's take for instance what the sine graph looks like. We know that it starts in the middle, goes up to its high, middle, low, middle. That's one cycle of it, but it keeps going. And so when I'm talking about a domain, domain is x values. And so what you'll see in this lesson is x's are going to now be given a domain that sometimes is pretty big, and then the next lesson will be sometimes small as well. And so what we're saying is if I know that this repeats its pattern every 2 pi, we would keep going. So that would be another 2 pi, which would put us at 4 pi, and then a 6 pi, and then half of a cycle would put us at 7 pi. I want to know, let's say, where all the sine values equal 0. So it's going to be 1 answer, 2, 3, 4. Get what I'm saying? You're going to have more answers. So that's our goal today, is just to take it up a notch and now find more answers because we have a bigger domain to find. Okay, so my first job is to isolate my trig function. So I've got tangent of 1/6 x needs to equal negative square root of 3. So I'm going to do this exactly like I've done before, just ignore this and say, okay, where is tangent? Negative square root of 3. So we know that's our 60s, but tangent is negative here at 2 pi over 3, and then also here at 5 pi over 3. Okay, so I'm going to kind of make a mark here just so you remember these are the angles. Okay, but now I have to solve for x. So I got to figure out 1/6 times what would make this. So I set it equal to 1/6 x, and I solve, which is simply going to be taking it times the reciprocal, which is 6. So 6 divided by 3, this can cross cancel, that's a 1 and that's a 2. Multiply straight across, I get x to be 4 pi. Is 4 pi less than or equal to 7 pi? Yes, so that's one answer. Okay, let's try this one. 5 pi over 3, set it equal to 1/6 times x, multiply by the reciprocal, divide by 3. That would now be 10 pi. But 10 pi is not less than or equal to 7 pi, so that one's out. So actually we didn't have to go very far. That's our only answer. Okay, number 2. We need to isolate our cosecant function. And we know that's one of our reciprocal functions. We've got divide by square root of 2. So that is cosecant of a third x needs to equal negative 2 over square roots of 2. There's no need to rationalize this denominator because I'm going to reciprocate cosecant into sine. And so this flips and becomes negative square root of 2 over 2. We flipped. Okay, so then I go to my unit circle and think, okay, where is sine square roots of 2 over 2? We know that's at our 45s. Sine is negative down here. So that would be at 5 pi over 4 and 7 pi over 4. Okay. And so then I got to figure out, well, I got to solve these so that I get 1/3 times something to equal this. So I'm going to set it equal to 1/3 times x. I'll multiply by the reciprocal, which is 3. I can't simplify. That would be 15 pi over 4. But I don't know if that falls within the 12 pi. So let's think about this. If my fraction is 15 over 4, let's just estimate it. If this were 1/4 bigger and was 16 divided by 4, think about that is 4. And it's not quite 16, so this is less than 4 pi. So that is going to work. That's one of our answers. Okay, now let's try our 7 pi over 4. Set it equal to 1/3 times x. Solve by multiplying by the reciprocal. You get 21 pi over 4. So again, ignore the pi. Let's just figure out what 21 over 4 would be. Well, it's close to 20 over 4. That would be 5. So this is just a little bit bigger. It's 5 1/4, which is still less than 12 pi. So that's an answer. But we need to try to keep going. So go back to your angle that you knew was an answer, this 5 pi over 4. We're going to add 2 pi, which is a whole revolution to it, saying if this is my angle here, another coterminal angle would be I add a complete 360 degrees to it and I end up also here. It would be the same shaped triangle. And so 2 pi is over 1. I would have to get a common denominator. So now I'd have 5 pi over 4 plus 8 pi over 4. 5 plus 8 would be 13 pi over 4. This is the angle. So this is possible angle number 3 that I'm going to solve for x. So I set it equal to my 1/3 times x, multiply by 3. 3 times 13 would be 39 pi over 4. 39 is close to 40. It's not quite 40. 40 divided by 4 would be 10. So this is less than 10 pi. And we can still go to 12 pi. So that's an answer. Okay, I'm going to take the second angle that I knew was an answer of 7 pi over 4, which is here. I want to find that if I went completely around my circle again, or I added 2 pi to it, what is that coterminal angle that would also be a solution to this? So I'm going to take my 7 pi over 4. I know I'm adding 2 pi, and I've already created an equation, or a equivalent fraction, which is 8 pi over 4. I always want these numbers to divide to make a 2 pi. And so that would equal 15 pi over 4. So this is angle number 4. Let's set it equal to my 1/3 times x, multiply by 3. 3 times 15 would be 45 pi over 4. I'm going to estimate here, if this were 44 over 4, that would be 11. And so this would be just a little bigger than 11, which is still good. But because I'm getting so close to 12 pi, I'm sure that I'm done. Okay, the other thing you could do, if you're not liking the fraction thing, is take 12 times pi, figure out what that decimal actually is, because that's taking 12 times 3 point something, so it makes sense that it's in the 30s. And then you can try all these numbers. So if I took 15 pi divided by 4, that's 11 point something, so it's definitely less than that. If I took 21 times pi divided by 4, that's less than 37. If I take 39 pi divided by 4, that's less than, what was my number? I forgot. 37. And if I take 45 pi divided by 4, that's less than 37. But the closer and closer you get, you realize I'm not going to have to try anymore because they won't work. So you get 4 answers. All right, and then number 3, our domain's pretty small here. It's only between 0 and 1. So I need to isolate my secant of 3x. I'm going to add 2. And then divide by the square root of 3. So secant of 3x would equal 2 over square root of 3. But I want to reciprocate this, change it into cosine of 3x. Now flip this to be square root of 3 over 2. Okay, figure out where cosine is square root of 3 over 2. That's looking at the x values. That would be on my 30s. So that would be here at pi over 6, and cosine is also positive here in quadrant 4 at 11 pi over 6. So again, this is only my answers for 0 to 2 pi. We're actually not even going to have pi. We have just 1, so we'll have to test these to figure out if they work. Oh, I'm sorry. I meant to write that these are my angles. Okay, so I set it equal to 3x. So now I know I'm dividing by 3, but I don't really want to write dividing by 3, so I'm actually, instead of dividing by 3, I'm going to multiply by the reciprocal 1/3 to make this easier on myself, and I get pi over 18. I'll test it here in a minute. Okay, my next one, and once you figure out how you're solving it, you could go ahead and just say, okay, I know to solve, I'm going to take it times 1/3, and that will speed you up as well. So that's 11 pi over 18. And I don't know what that is, so let's test. Take pi divided by 18. Very small. It's 0.17, and that is less than 1. So that is an answer. Okay, let's try 11 times pi over 18. And that is 1.9, so that's too big. If it weren't, then we would have to go back to our angles of pi over 6 and 11 pi over 6, add 2 pi to them, and then solve it by multiplying by 1/3 and seeing if those decimals are less than or equal to 1. But that is my only answer.